Today we're going to be talking through the Unit 8 test review, so I'm going to quickly run through a couple of these examples and I'll give you all of the answers here at the end of this as well. So quickly just running through a couple in this first section here, numbers 1 through 6 ask us to evaluate each expression. So really I just need to know, what does this thing equal? So in the end this can really just go straight into your calculator, but we do have to remember and how to type in these different roots that are not square roots. So easiest way to do it is to start with the root that we're trying to take. So if I'm doing number 1 here, I want to type in the 5 first, then I go under the math menu and I go all the way down to option 5 here. Is that root with the x on the front? The x is the number that I just typed in before I went in here. So I can type that, and then your calculator will change that automatically to a 5th root. I can type in my negative 248,832 and hit enter, and I get my answer of negative 12. So that is my first answer there for number 1. There is another way to do that one as well. You can take the number that we're trying to take the root of, so our negative 248,832, and I can type it to the power of, in parentheses, 1 divided by 5. And that 1/5 is really the same thing as the root of 5. We talked about how our roots are related to rational exponents, and that the type of root I'm taking, we can take that fractional exponent or that rational exponent of that same number. So I can do the 1/5, and you'll see that gives me the negative 12 as well. Okay, so 1 through 6, you can pretty much type those all in. I do want to quickly talk about number 3 here. Number 3 is the 6th root, so I'm going to go ahead and get the 6th root here. The 6th root of negative 15,625. So the 6th root, or an even root of a negative number, is always going to cause this problem. We get an error on your calculator that there is a non-real answer. So for us, we're going to go ahead and just say that this is no solution. You can do the 0 with a line through it. I'm just fine with that. And that will work any time that we end up with a root of a negative number, and that root is an even root, meaning it's a 4, a 6, a 2, something like that. Okay, odd roots are fines of negatives. That's what we did in number 1, but those even roots you got to be careful with. Okay, next one I'm going to move down here to number 8. We're done with the calculator for a bit here, so I'm just going to set that off to the side. Number 8 here, we are trying to write each expression as a single rational exponent. So I need to write it as one exponent that is a fraction. So I need to take all of my different roots here and start to write them as fractions. So I'm going to start on the inside. I start with my 12p. I'll go ahead and throw that in some parentheses there. And the first one I have is a square root. Now a square root really has a 2 on the front there. So as an exponent, that is a 1/2. We always take the number from the root and we put it to the denominator of our fraction. Then I can move to the next one out, which is a 1/3, or a cube root. And then the last one is a 1/6. Make sure we get our parentheses in there. Okay. From there, I need to combine these exponents all together, but this is a power to a power to a power, which means we're multiplying. And if I'm multiplying fractions, I go straight across the top and straight across the bottom. So across the top, I have 1 times 1 times 1, which is just 1. And on the bottom, I have 2 times 3, which is 6, times 6 gives me 36. So I end up with 136. Now that's in the exponent of the original thing that I was taking the roots of, which is our 12p. Next one I'm going to look at is number 10. Number 10 here, again, I have the g to the 5th in the middle here. So we'll start with g to the 5th. On the outside of that, I'm going to go to the 4th root, or a 1/4 power. And then on the outside of that, I have a 1/5 power as well. Okay, from there, again, I need to multiply. Now this one's a little bit trickier because I do have some stuff in the top. So 5 is really a 5/1. So in top of these fractions, I have 5 times 1 times 1, which is 5. So I'll g to the 5th over, on the bottom I have 1 times 4 is still 4, times 5 is 20. Now this one we have to go one more step here because 5/20 can be reduced. Okay, 5/20 is the same thing as 1/4 if I pull that 5 out of both the top and the bottom. Okay, so your answer here to 10 is g to the 1/4. Okay, moving down to numbers 11 and 12. 11 and 12 are virtually the exact same problem. This problem is going to show up on your test as well. The only thing that's going to change is the type of root and the exponent that's here, but as long as these match and they're even, we're going to run into the same problem we're going to talk about here. So I'm going to go ahead and do number 12. We need to write a counterexample to this statement. So a counterexample is just a example that doesn't work. So I need to pick a value of m that doesn't work. Okay, I'm going to say that our value of m is -2, and we'll talk through this one, and then we'll see what other values of m would also work. So I'm going to go ahead and take that -2 and plug it in for m. And essentially, once I plug that in, this really just becomes like a check when we're solving. So I have my m plugged in. I just want to see, does this thing actually work out? So I'm going to do negative 2 to the 8th power. When we do that on a calculator, you have to make sure this goes in parentheses. Anytime we take a negative number and raise it to a power, those parentheses are really important. So I'm going to take the 8th root of 256, which is still going to equal the negative 2 because I'm not doing anything to the right side. And if I take the 8th root of 256 on a calculator, I get 2. So I end up with 2 is equal to negative 2, which we know is in fact not true, and that's the reason why this is a counterexample. It doesn't work out. Okay? Now, I use negative 2. In the end, m can really be any negative number. And the only thing you really have to do for whatever negative number that you choose is you just need to do a quick little check, show me that it doesn't work out. Okay, and make sure you do that on your test as well. That's how you'll be getting points for that problem. Okay, on the back, let's go ahead and jump over to some of these solving ones. So, I'm going to do 2 of these. I'm going to do both 13 and 15. Okay, to start with number 13, I am trying to get this root by itself, so the cube root of a plus 5. To do that, the only thing that's not in the root is the 4, so I need to start by moving that. So I'm going to add 4 to both sides to cancel out with the minus 4. Okay, negative 2 plus 4 gives me a 2, so this is going to be the cube root of a plus 5 is equal to a positive 2. Okay, from there, I don't have anything outside of the root, so the next step is to get rid of the root, and we do that by raising it to the power. That's the same as the root. So if I have a cube root, we raise it to the 3rd power. Okay, that cancels out my root, and I'm left with just a plus 5 on the left-hand side, and 2 to the 3rd gives me an 8. We can then subtract the 5 on both sides, and we end up with a here is equal to 3. Now, the one thing we do have to do for all of these solving problems is we need to check these. So I need to take my cube root of a, which was 3 plus 5. I'm going to subtract from that a 4, and I want to know, does that equal the negative 2 that I started with? So let's go ahead and work through this. 3 plus 5 is 8. So this is the cube root of 8 minus 4 is equal to negative 2. Cube root of 8 we can do on our calculator is 2. So we have 2 minus 4 is equal to negative 2. 2 minus 4 is in fact negative 2. So we get negative 2 is equal to negative 2. Everything checks out. So 8 is equal to 3 is in fact a solution. It is not extraneous. Okay, let's talk about number 15. Number 15 is the same process. It just looks a little bit different because I have 2 separate roots here, and I'm not going to be able to solve for 2 separate roots. So we need to start by getting those 2 roots together, which are really like terms. So I'm going to say that this square root of x is really my term that I'm working with. So I have 11 minus 7, which is 4, square root of x is equal to 40. Okay, then we can go ahead and solve from there by dividing by 4 on both sides, and we get the square root of x is equal to 10. Then to get rid of the square root, because again this is really a 2 on the front, we raise it to the 2nd power, and 10 to the 2nd power is going to be 100. So we get x is equal to 100. Now a quick check on that one is as well. We have 11 times the square root of 100 minus 7 times the square root of 100, and we want to know, does that in fact equal 40? Let's go ahead and check it. Square root of 100 is 10, so this is 11 times 10 minus 7 times that same 10 is equal to 40. 11 times 10 is 110 minus 7 times 10 is 70 is equal to 40. 110 minus 70 is going to be 40, which is equal to the 40 that we have. Everything checks out, and 100 is our answer. Okay? If this check does not work out, remember the phrase that we use is extraneous. Okay? Extraneous is that word for everything worked out as well as it possibly could, but our answer still in the end did not satisfy your equation. Okay, let's talk about 17. So there is a story problem here. This is a very similar story problem to what you will see on the test. So we're working through this one. As we read through this, we're talking about volume of the sphere, and its radius is given by this formula. We want to find the radius for a sphere with a volume of 1040. Now that's really the only information that I'm given is that 1040, so I need to plug that in. That is the volume, so that's going to go in for V here in the equation. Which if I do that here, this is going to be r is equal to the cube root of 3 times 1040 over 4 pi. Okay, and for pi, we're going to use just 3.14. So I'm going to start by simplifying the top and bottom of these fractions. So I'll do 3 times 1040 gives you 3,120. And on the bottom, 4 times pi is going to be 12.56. If we go ahead and divide that out, I'm still all inside the square root here, which is 248.408. And all of these numbers are just coming from your calculator. I've just already done them, so I don't need to type them in again. Okay, the cube root of that number, when you type it out into your calculator, is going to give you 6.286 if we round that off. So this here is our answer for our radius. Okay, and again, there'll be a very similar one to that on your test as well. Okay, we're going to do 2 more from this bottom section here. These are simplifying our square roots here. So I'm going to start with number 20. Okay, when we have a whole bunch of stuff under one square root like this, our first step is to always split it into little chunks. So we square root the number, and then we square root each variable separately. So I have the square root of 324, the square root of a to the 4th, the square root of b to the 5th, and the square root of c to the 6th. Okay, square root of 324. That is not one that I would necessarily expect you to know, but you do have a calculator to check this out here. So I could try the square root of 324, and look at that. It actually does work out for us. So we can use that 18. We can just jump right to the 18. We don't need to split it apart or anything like that because it is a perfect square. From there, we can square root the a to the 4th. Square root of a to the 4th is going to be half of those 4, which is a to the 2nd. b to the 5th is a little bit trickier. Whenever we have an odd number like that, we cannot evenly take the square root, so we're going to split just one of them off at the end here, and whatever we're left over with will also square root. So if I take 1 out of the 5, I'm left with 4, so I'll have the square root of b to the 4th and the square root of b. We'll deal with that one in our next line. Okay, and then we have c to the 6th, square root of c to the 6th. Again, just like the 4, we can split in half, so that's going to give us a c to the 3rd. Okay, as I continue down my line here, I'm going to bring down the 18 and the a squared. The square root of b to the 4th, just like a to the 4th, is going to be b to the 2nd. Now, at the end here, I want to take the square root of b and actually throw it to the end, so c to the 3rd is going to come next, then the square root of b. And that is all that I can do. That is your answer. The final one I'm going to do here is number 21. So number 21, we're going to take the square root of 72, and we're going to take the square root of k to the 13th. Okay, we're going to do those two separately. So the square root of 72 I can split apart. The number that we're going to want to use there is 36 and 2. Okay, 36 times 2 gets us to the 72. 36 is nice because it is a perfect square. I can take the square root of that, which is what we'll do in the next line. Okay, the square root of k to the 13th I can split apart into k to the 12th and just a single k at the end there, just like we split our b to the 5th over here for number 20. If I go ahead and continue here, square root of 36 is a 6. Square root of 2 I'm just going to bring down. Square root of k to the 12th is k to the 6th. And finally, the k at the end just stays in the square root. Okay, last thing, because I have 2 square roots here, I can combine those together into 1. And that k to the 6th is going to move to the front. So my final answer here is 6k to the 6th square root of 2k. And that's our final answer. So those are all that I'm going to go through. The next thing I'm going to do here is I'm just going to show you some answers. So this is from the very front page. So you can see numbers 1 through 10 here. So I'm going to go ahead and give you a chance to work through those. I'm not going to wait too long, but if you need to pause the video to look at them for any additional time, feel free to do so. Moving down to the bottom here, I'm going to jump down to numbers 11 and 12. 11 and 12, again, you can really pick any negative number that you want. In the example I went through, I used -2. You could use -1, -3, -4. Doesn't really matter. As long as it's negative, you're going to have that same problem that we ran into. My one suggestion is to keep the numbers small. If you start to get into larger numbers, you're going to run into problems with your calculator not showing you the whole thing or something like that, which are just issues we don't need to run into. So keep the numbers small. Try and stay probably less than 5. And use those as you check them. Okay, and show that check as well. On the back here, okay, we'll get numbers 13 through 17. Okay, 13 through 16 were your solving ones. You do need to make sure you're checking all of these. I did not show the check for these, but all of them did work out. That may or may not happen on the quiz. We know that if that check doesn't work, we need to say that our answer is extraneous. Okay, but you still need to show all of that work. I'm expecting you to see that solution all the way through, then through the check, and that's how you're going to get all of your points. Okay, and then number 17 we talked about. There's your answer for your radius. And then finally down here at the bottom, these are our square roots. You can go ahead and check through those. Couple of quick things with these, you do need to make sure they are in the correct order. So numbers on the outside of square roots always come first, then any variables in alphabetical order that are not inside of the square root. Then at the very end is where the square root comes, and then the same order applies inside the square root as well. So numbers first, and then variables in alphabetical order. Okay, so that is your review. Just a couple of reminders before you start on your test here. Make sure you are showing all of your work, and make sure you are checking your work for the ones that you are solving. So as soon as you see the word that you need to solve, you also need to check. You cannot just solve those, you need to check your equation as well. Okay, make sure you're showing all of your work. That's going to be how you can get partial credit, which will help a lot of you out if you're getting wrong answers. That partial credit can save your grade. So good luck with your tests. I will talk to you later.